Hello, welcome to our second lesson. In this lesson, we are going to look at deviation of a reflected ray by a rotated mirror. We shall also look at deviation by successive reflection at two inclined mirrors, and then last we shall look at the sextant. Let us begin by looking at the deviation of reflected ray by a rotated mirror. So we have this mirror M1, and we have a ray AO, and its reflected ray is going to be OB, and its glancing angle is G, which implies that its angle of deviation is going to be twice of G. Now when we rotate this mirror to position M1 prime, the reflected ray will be OB prime. Therefore its glancing angle is going to be G plus theta, and therefore the deviation is going to be COB prime, which is twice of G plus theta. Now this ray, the reflected ray, will have rotated through an angle B or B prime. So remember, it was here and now it is here, so it means that it would have rotated through the angle B or B prime. Now if we want to get that angle B or B prime, we shall get C or B prime minus C or B. When we subtract the two, we shall be able to get B or B prime. Now C or B prime is given by twice of G plus theta. So we shall get twice of G plus theta minus 2G, which is the C or B. And when we subtract that, we shall get 2 theta, which implies that the deviation of the reflected ray by rotated mirror is twice the angle of rotation. Let us also continue and look at the deviation by successive reflections at two inclined mirrors. So here we shall have two inclined mirrors, M1 and M2, inclined at an angle theta. So we have this ray being reflected at this point A, and then again being reflected at B, and finally it gets out that direction. So it implies that the deviation of M1 is going to be given us twice of alpha, since alpha is the glancing angle of M1. This is in the clockwise direction. We are measuring this in the clockwise direction. Also, the deviation at M2 is going to be given us twice of beta, since its glancing angle is beta. If we want to get the total deviation, we shall add the two deviations, and therefore we shall get twice of alpha plus beta, still in the clockwise direction. Now from the geometry of the figure, alpha plus beta plus theta is equal to 180, because they are interior angles of a triangle. And therefore, we shall have alpha plus beta being 180 minus theta, 180 degrees minus theta. Now when we replace alpha plus beta here, we shall have the total deviation being twice of 180 degrees minus theta, which gives us 360 degrees minus 2 theta, still in the clockwise direction. This can be shown also that in the anti-clockwise direction, it will simply be 2 theta. That is in the anti-clockwise direction. So the deviation by successive reflection at two inclined mirrors will be given by twice the angle between the two inclined mirrors. Yes, lastly look at the sextant. This is how a sextant looks like. A sextant is a device used for measuring the angle of elevation of a star or the sun. Let's see how we can use the sextant to measure the angle of elevation of the star. So the diagram we shall be using is this one here. So here we have a sextant consisting of the scale here, then we have these 2 mirrors, M1 and then M2. M1 is fully silvered and it is movable. M2 is half silvered and it is half silvered, meaning that half silvered means that one side is silvered and one side is not silvered. This side is silvered and the other side is not silvered. And also M2 is fixed. I also have this diagram which will help us to understand this better. So we shall have, for example, this. You can see that if this is the second mirror here, M2, then this one here, this side here is not silvered, and then this side is silvered. So this is a half silvered mirror. While for this one, this is a fully silvered mirror, and this is fixed. So first of all, what we are going to do is to make sure that M1 and M2 are parallel to each other. How to achieve that is by focusing an horizon H. So the image of H after successive reflection at M1 and M2 must coincide with the image of H prime after passing through the unsilvered part of M2, directly through the unsilvered part of M2. Then here from horizon H, the ray will go through the unsilvered part, through the silvered part of M2, and then to the telescope here. This is a telescope and this is its eyepiece. So when those two images coincide, then we measure this angle or this position M1, which is given as θ1. So what are we trying to say there? It means that our image will appear like this. If this is the eyepiece, it will look like this. This is going to be looking like this. So the silvered part is this side, the unsilvered part is this side. So it means that the image of the horizon seen through the silvered part, will be this, and seen through the unsilvered part will be this. So you can see that these two images are coinciding. So that's what we want to achieve. After achieving that, we record this angle, this position θ1. Then after that, we shall focus the star whose angle of elevation we want to determine. When we focus the star, we also want to make sure that the image of the star after successive reflection at M1 and the silvered part of M2 coincides with the image of H prime seen directly through the unsilvered part of M2, and it will appear like this. So you can see that this is the star seen through the silvered part of M2, and this is the horizon, which is the ship, seen through the unsilvered part of M2. Now when in this first case, before we achieve coincidence, it will be appearing like this. But when we achieve coincidence, it will be like this at A. And also in the second case, for the star, it will be like this. Now after achieving the second case, that is when the image of the star is coinciding with the image of the horizon, we shall measure the new position of M1, that new position. Remember, this M1 is movable, so after rotating it, we shall measure that new position, θ2. When we measure that position, and we also have this position θ1, for us to get the rotation theta, that angle of rotation theta, it will be the difference between θ1 and θ2. That difference is what we need. That difference will be the angle of rotation here, theta. After getting that angle theta, we shall conclude that the angle of elevation of the star is twice of theta. Thank you for attending this lesson. See you in the next lesson.